Hey friends, so the last time we were together, we talked about those branch diagrams that were working on before we left after this crazy school closure. Today I want to talk about the rectangle models that we also were working on before we left. This page is going to be found in packet 3. So make sure when you're looking at your packets, there's going to be those black numbers at the top. Make sure you're on packet 3 for today. And go ahead and flip past where we were working on the tree or the branch diagrams, and let's go to the rectangle models worksheet. Now, just like the last worksheet, I've included some instructions at the top to get your brain remembering what we're doing. But a couple important things to remember. With the branch diagrams, it was all addition and subtraction. However, with these rectangle models, they only have to do with multiplication and division. So we're going to switch our brains. We're no longer working with the branch diagrams and adding and subtracting. Now these models are going to help us with multiplying and dividing for unknown numbers. Remember, when we have an unknown number, we use a letter to fill its place until we're able to solve what that number is worth. So looking at some of these examples, just like with the branch diagrams, it matters where that missing number is. Where it is, it tells you whether you are going to be multiplying or dividing. So for example, if that missing number is inside of your rectangular model, you are going to use multiplication to figure it out. When it's on the inside of the model, it means that it's the biggest number in that model. So you're definitely going to be using multiplication to try to solve it. For this particular problem, we've got 70 and 20. So I know when I multiply those two together, that my missing number is going to be 1,400. For this one down here, notice that my missing number is no longer on the inside, but it is on the outside. That is my indication, that is my clue that I'm no longer going to be multiplying these two fractions together, but I am going to be dividing. Now friends, please keep in mind when you're multiplying, the order of the numbers does not matter. Just like in addition, however you flip it, whichever number comes first, it does not matter. However, with subtraction and division, the placement of the numbers does matter. So in the branch diagram, we said whatever number was at the top needed to go first in your subtraction problem. For these rectangle models, whatever number is in the middle of the model, since that's my biggest number, is always going to be the first number in my division problem. So for this particular answer, to try to solve what S is equal to, I'm going to take that 5, 6 from the middle, and I'm going to divide it by the other fraction that I know, which is 1/3. When I do that, I gave you a little bit of a clue up here. Remember, when you divide fractions, you need to flip the second fraction. So instead of being 1/3, you're going to flip those numbers and it's going to be 3/1. Once you flipped those numbers, now you're no longer dividing, but you are multiplying. So make sure that you change that symbol. And then when you're multiplying two fractions, remember, this is the easy part. You have to multiply the tops and then multiply the bottoms. So I find it easier to look at these fractions like this, so I can keep straight what ones are on the bottom and what ones are on top. So when I look, I'm going to multiply 5 times 3, and I know that's 15. And then when I look at the bottom, I'm going to multiply 6 and 1, which is easy peasy. That's 6. Now, I showed you a way to change that to a mixed number. So my friends who know how to do that, there's a little extension there. But for my other friends, this is all I expect of you. All right? So just like with the branch diagrams, I've given you 10 practice problems. Flipped one too far. I've given you 10 practice problems to do on the back side. And I would like to go through just a couple like the last time with you, so you feel a little bit more confident trying these on your own. Let's start with problem number 2. So we're going to skip number 1 because I think that one should be easy. And we're going to start with number 2. Now, I first need to decide, in order to find what y is equal to, am I multiplying my two known numbers or am I dividing them? Remember, since my missing number is on the inside of my model, I know I'm going to be using multiplication to find that answer. So I'm going to be taking the 20 and the 80, which are the two numbers that I know, and I'm going to multiply those together. Now, friends, you could set this up and do a lot of work. You could set it up and do 20 times 80 and do all kinds of work. But kiddos, remember, when you have big numbers like this with zeros at the end, you can just multiply the 8 and the 2. And I know 8 and 2 is 16. And then I can put those zeros back in. So I've got 1 0 here for the 80, 1 0 here for the 20. So I can just put those zeros right back in. And my solution is going to be 1,600. It's been a little while since we reviewed that, but you don't have to go through all the work. You just have to multiply the two numbers that are there and then figure out how many zeros you need to put back in your answer. Okay, remember to solve this completely, we talked about this in the last video. I like you to put the Y or the missing letter that's right here equals and then your final answer. That is the way that you write your equation in answer form. That looks perfect. All right, kiddos, the next one that I would love to do with you guys is another fraction one. So let's go ahead and go down to number 9. If you look at number 9, my missing number is represented as an S, and it's on the outside of my model. I know that when the missing number is on the outside of my model, I need to use division in order to find it. However, I want to make sure that my division problem is in the right order. It cannot just be 1/2 divided by 3/8 or 3/8 divided by 1/2. It has to go in a very specific order. I want to start with the number that's in the middle of my model. Just like in subtraction, you always want to start with the biggest number. On the inside of your model, that's going to be your biggest number, so you always want to start with that. So now I'm going to write 3/8, and I'm going to divide it by the other number that I know, which is the 1/2 that I have on the outside here. Now, kiddos, when I'm dividing fractions, I need to first flip the second fraction. We've talked about how it cannot be the first, it's always going to be the second. When I flip 1/2, I now have the 2 on top and the 1 on bottom. I just flipped them and I changed the order where the numbers were. Now that I flipped that second fraction, I'm no longer dividing, but I'm multiplying. And remember, we've talked about multiplying fractions is so easy. I just have to multiply the numerators or the numbers on top. So 3 times 2, think about it. I got 6 on the top. Hopefully you did as well. And then on the bottom, I need to multiply my denominators. So I've got 8 times 1. Think about it. And I got 8 as well. Now for my friends who remember how to reduce these fractions, I know that 6/8 can be divided by 2 on the top and bottom. So 6 divided by 2 is 3, and 8 divided by 2 is 4. If you know how to simplify fractions, great. Hopefully that was helpful. If not, that 6/8 works perfectly fine as well. But oopsie, I messed up. I need to make sure I put the full equation, which is that S equals 6/8. That's my final answer, and I'm going to circle that with my final answer as well, because that's my whole equation that Mrs. Hefner wants. So hopefully that was helpful. That means you have 8 more left to go. I believe in you. Try your best on these, and if you need my help, let me know. Bye, you guys.